Hello everyone, welcome to today's webinar brought to you by Danfoss. The topic for this session is increasing seawater reverse osmosis plants efficiency with axial piston pumps and isobaric energy recovery devices. My name is Kalai and I'm your host for today. Together we have our presenters, Mr. Kevin Evald, HPP Product Manager all the way from Danfoss, Denmark. And we also have Mr. Vijaya Kumar Subramaniam, Sales Manager from ASEAN region. Now, before we start, I would like to remind you that the session is recorded and a few practical information over here. So you will see on your screen, this is where you can look at the slides. And if you want to go to full screen mode for the slide presentation, you can click on this button over here. You will also be able to ask questions throughout the session over here. And you can also download references over here on the right top corner. And if you would like to get in touch with our presenters from today, you can email them over here. All right, without further ado, I will now pass it on to Mr. Kevin.
Yeah, hi guys. Thank you for visiting us today. I'm Kevin Evald, and I'm the product manager in high pressure pump for the RO products going into seawater desalination plants. I'll talk to you today about our products within this segment. The desalination segment in HPP, high pressure pumps, is 1 out of 5. We are also providing products going into gas turbines, firefighting, flat panel cleaning, and humidification. But the branch we're talking about today will be desalination and the two main products going into this segment. So really, the products that is going into the desalination applications are APP pumps and iSaves. The iSaves is energy recovery devices used to optimize seawater plants and save energy, obviously. These are used for the marine and offshore business. They are also installed on land-based systems and for hotels and resorts. We also have products going into the mobile applications within containerized systems, etc. So these products are highly energy efficient, and our axial piston pump is built on a known technology that Danfoss have mastered for the last 20 years. As some of you probably know, Danfoss is a huge provider of mobile hydraulics, and a lot of the experience we have within these products are coming from that business as well. The efficiency of these products, or the APP pumps, are up to 92%, which is really a key when selecting pumps within desalination. The pumps can be delivered as systems, or they can be provided bare shafted. They can easily be extended to cover larger flows by running more pumps in parallel. The pumps are available from flow from 0.15 cubic meters per hour and all the way up to 92. The pressure range is from 20 or 10 bars and up to 83 bars. The materials that these pumps are provided in is super duplex, or it's a combination of super duplex, and carbon fiber reinforced thermoplastics. So the APP pumps are offering the highest energy efficiency on the market when it comes to pumps. This is basically because of the positive displacement technology that is used in these pumps. You thereby get your lowest energy consumption and compared to any other pumps on the market. And the efficiency, as I said, was up to 92%. If you compare them to other pump technologies, the savings can be up to 16%. So they have a huge impact on your efficiency of the plant. The efficiency is constant, so it's regardless of flow and pressure. The pumps are not affected by any pressure variations on your membranes. They simply provide a flow no matter what pressure they are set up to give. The efficiency level will stay the same over the time. So these APP pumps offer a very easy and predictable operation. There's full control of your life cycle costs due to the predictable inspection intervals. You get a proven and very reliable technology with a few moving parts. This allows you to do inspections easily on site and only in a few hours. They are very easy to take apart and service. And once you have taken them apart, there's no you actually get a pump as good as new, because the wear parts are typically also the ones. There's a few wear parts, and once you change them, you are back into the same level as when you bought the product. There's no oil in the pumps. They are lubricated by the media itself. This makes it very easy to service as well, because you don't have to handle fluids and so on. You can just take it apart and change the parts needed to be serviced, and then that's it. There's no special alignment needed either. The pumps are mounted with a fixed bell housing. It means you are not required to have any special tools to do alignments and so on. You simply install the pumps on a bell housing, and the bell housing will align the shafts due to the flanges, how they fit together. This again makes it very easy to install and service. So the APP pumps are very small, and this of course makes them ideal where you need to save space. This of course also reduces your capex and opex due to you don't need much space to install them. The piping, you simply have a pressure cut or water coming into the pump and water coming out. There's no drainage, there's no relief of housing pressures and so on. They can be installed vertical or horizontally. They are very easy to handle. There's no need for heavy lifting equipment. The bell housing makes it simple for shaft alignment between the motor and pump. And then the flow is easily controlled by adjusting the RPMs. So placing more pumps in parallel is also very simple, because they are not really affecting each other. If you set an RPM, it will be proportional to the flow. So if a pump is set up for 1500 RPMs and to give maybe 30 cubic meters, it will provide at 1500 RPMs, it will provide the 30 cubic meters no matter what pressure you have in your RO system. If you increase the speed by half, you also decrease the speed by, you also decrease the flow from the pump by half. So they are proportional to speed and flow. Compared to other pumps, where pumps, if you place them in parallel, they may influence each other. This is not the case with the axial piston pumps. So you can place as many as you want in parallel, and they will not really affect each other. So it's one of the bigger benefits as well. Then we have another product that's the iSave, the energy recovery device. This is a 3-in-1 unit, which makes it very compact. The design allows you to produce more water in less space and with a less complexity. The iSaves can be delivered as systems, or they can be delivered as bare-shafted ERDs as well. They are very simple to set up. The flows the range of the products is from the iSave 21 and all the way up to the iSave 70. As you can see under the iSave 21, this will cover a flow from 6 to 22, and the iSave 40 will cover a flow of 21 to 41 cubic meters per hour. Then the iSave 50 will take 42 to 52 cubic meters per hour, and the iSave 70, 50 to 70 cubic meters per hour. And this is the flow range is controlled by the speed of the electric motor. The maximum pressure for the iSaves are 83 bars, and the materials is just like the APP pumps, made out of super duplex, and carbon fiber reinforced thermoplast. The technologies that goes into the iSaves are more or less based on the same as the pumps, although there's no pistons in the ERDs like there is in the pumps. So the iSave ERDs offer a very simple installation. This 3-in-1 unit makes it very compact. You get a device that fits in where space is limited, and the design allows both vertical and horizontal installation. And this also makes, handling in remote areas is easy, so because there's no need for heavy lifting equipment either. So with the iSave ERDs, we offer you a high energy efficiency, reducing your OPEX. The ERD technology that we are using is the Isobaric pressure exchanger concept. This energy efficient, or the energy efficiency is rated up to 92%. And this includes the high pressure booster pump, because this 3-in-1 unit is including a booster pump for compensating for any pressure loss on the membranes. The Isobaric technology is known to be the most energy efficient ERD technology, so it offers up to 30% lower energy consumption than other ERD technologies. The iSave setup makes it very easy to optimize your system. The VFD is controlling and secures an optimal operation. Yeah. So all the iSaves needs to be operated on a VFD. So the iSave ERDs are simple to use and operate. The iSave ERDs are designed for automatic and fail-safe operation. The rotor spinning is controlled by the electric motor and the VFD. This is eliminating the risk of overspin or overflow during startup and operation. The flow is just like the pumps. It is controlled by the speed of the ERD. So you get a constant flow out of the pressure exchanger that is proportional to the RPMs that you're providing. So this also makes it possible for you to control your recovery rate, because you can control the flow from the ERD going into the membranes, and thereby you can control your cross flow on the membranes as well. So you get a very reliable and low maintenance performer, which has which are easy to service in the field. You're using standard tools. There's no special tools required to service the iSaves. It's an ideal solution if the plants are operated by changing staff with varying skill levels, simply because there's manuals for everything to operate these ERDs. The frequency converter allows you for easy monitoring, so you can easily check on your ERD if it is rotating, first of all, but you can also see how it is performing based on history or over time. You can see what the power consumption is from the start, and you can see it after 3-4 years, how it has been developing. So if we look at the Danfoss iSave ERDs compared to other isobaric pressure exchanger systems, then because we have this 3-in-1 system or component, you are saving quite a few cost items and reducing your capex. So on the left side, we have the Danfoss iSave solution. We have let me just see if I can get a pointer here. There you go. So we have the axial piston pumps from Danfoss. We have a check valve providing making sure that flow cannot go backwards through the pumps. These are providing flow to the membranes, as well as the ERD, the Danfoss iSave, is providing flow. The brine is collected from, or is sent from the membranes into the iSave, and is exchanged, and then the booster pump that is already connected, or part of the ERD, is then sending the water up to the membrane again. Compared to the Isobaric pressure exchanger system, then they typically require a booster pump to be placed after the ERD, also check valves, and because of the positive displacement pump that Danfoss is using in the iSaves, we are also saving the flow meter that is required to control your flushing rate. So you're not only getting a 3-in-1 solution, but you're also saving components and connections in your system. So some of these comments is coming here in the next slide as well. So the design complexity, if we look at that, the design complexity is low. The required functions are already integrated in the Danfoss iSave. We don't need the booster pumps, the flow meter, the pressure exchangers are connected by, we don't have as many connections to connect the pressure exchanger. The iSaves are also very easy to commission. You adjust the iSave VFD until the required flow is achieved. The flow control, if you look at other isobaric pressure exchangers, they are using typically a centrifugal pump for a booster pump or something. And the flow control loop for the booster pump must be tuned before adjustments can be made. The flushing of the pressure exchanger is the same. There's no difference there. The flow stability, there's a change in feed. If there's a change in the feed temperature or the salinity, the iSaves are very stable because they are not really affected by any temperature or pressure changes on the membranes. Because of the positive displacement pump, is just delivering the flows that are set by the speed of the ERD, and compared to the conventional isobaric pressure exchange system where you use a centrifugal pump, you'll have to do some adjustments to compensate for any pressure differences in the system. And again, because we have the motor installed on these iSaves, there's no risk of the motor there's no risk of seizing the rotor in the exchanger by either biofouling or scaling. The motor will make sure that the iSave is always rotating. So there's no risk of mixing caused by a faulty exchanger. Then when we look at the Danfoss iSave versus a turbocharger system, this is a slightly different system setup. And as you can see, we have the same setup as before, showing the comparison before. But when looking at a conventional turbocharger system, this is also a fairly simple setup. But as you can see, the turbocharger is boosting the pressure from the centrifugal pumps that is typically used for the high pressure pump, and then it is using the boosting. The booster pressure is defined by the brine concentrate coming back from the membranes. If we compare the two, then we have the design complexity is fairly low for both solutions. The main difference here is that for the iSave solution, the iSave is providing both pressure to the system, or compensating for the pressure loss through the membranes and through the iSaves. It is also contributing with flow, whereas if you look into the turbocharger, it is only providing pressure. So whatever flow is coming from the brine concentration of the membranes are simply used to rotate your turbo and provide pressure, but the flow is lost afterwards. There's no water coming from the turbochargers. So this means that you have to size up your high pressure pump when using turbochargers. And again, this will add cost and so on for your system setup. The commissioning of the two systems are also fairly easy. The iSave is simply adjusted by the speed of the VFD, whereas on the turbocharger you have to control the pressure in the loop, and you have to ensure optimal performance. You need to be sure what kind of pressure you have available from the brine concentration, because it will affect your system setup. And again, if you're using turbochargers and centrifugal pumps, you can easily go out of the best efficiency points with these setups. For the flushing of the pressure exchangers, this is the same procedure. For the turbochargers, there's no need. There's no mixing. It's slightly different for the isobaric pressure exchangers, because here you do need to control your flushing. Flow stability, there's a change. If there's a change in the feed temperature or salinity, that's what I was talking about before, that this will be very affected on the turbocharger systems, whereas on the Danfoss iSave solution combined with our axial piston pumps, it's not really an issue as such. The energy efficiency is very high on the Danfoss iSave solution, simply due to the positive displacement pump and also the isobaric pressure exchangers. These are both very efficient technologies being used. The turbocharger systems are using kind of a centrifugal pump concept and has a very low efficiency by the technology itself. So this, of course, makes it fairly costly to use compared to isobaric pressure exchangers. Just to give you an idea about how efficiency is affecting the operation of, affecting the use, then if you compare the Danfoss iSave versus a turbocharger system, and here we are just comparing the system where we had, like we saw before, where we had the APP pump and iSave compared to a centrifugal pump and a turbocharger. The permit production in this example is just 1,000 cubic meters per day. Feed pressure on the membranes is 60 bars. The recovery rate is set to 40%. Then when you put these into configuration tools, then you get a specific energy consumption for the Danfoss iSave solution of 2.05 kilowatt hour per cubic meter permit. And for the turbocharger system, you get a specific energy consumption of 3.32 kilowatt hour per cubic meters permit. So if you calculate these into values, then the energy savings when supplied by the public grid, here we're saying $0.15 per kilowatt hour, over a 5 years period, it would be $350,000. This is a lot of money that you can save by choosing the right technology here. You could also, if you get your electricity from a diesel generator and you $0.40 per kilowatt hour, then it would be $927,000. These are typically what we see on smaller islands where they don't have electricity from anything else but diesel generation. If you look at the diesel savings when supplied by a diesel generator with a $0.77 per liter or over a 5 years period, then it would be $477,400. In diesel, for these generators, it would be 620 cubic meters of diesel that you could save by not or by using an iSave and an axial piston pump solution. So this is quite a lot. Okay, I think that was all from me. I'll give the word to Vijay. Are you there, Vijay?
Voila. Hi, Kevin. Can you hear me?
Yes, now we hear you.
Okay. Thank you very much,
Okay.
Kevin,
Thank
for
you.
the wonderful presentation. Good to see a lot of friends and known associates been joining this webinar today. Unfortunately, most of us are been confined to our home or to our countries actually without traveling. So I'm going to share an exciting location as one of our case study, which is in Maldives. Maldives is a country you must visit if you love looking at seas and sea sports, if you enjoy doing sea sports. Voila. This is one of the latest multi-island resorts complex. This resort is a man-made island. It is also known as Crossroads, and it is very, very close to Mali, the capital, which is only about 15 minutes boat ride, actually. This is probably one of the closest and beautiful island to visit, actually. If you guys enjoy go to sea spot, you must go and stay in one of these resorts here, actually. These multi-island resorts comprise of Sai Lagoon Hotel, Hilton, and also Hard Rock Hotel is there situated in that building. So what they did was they wanted to have a common facilities to provide the water for the whole 3 hotels and the other amenities within that multi-island resorts complex, actually. So one of the challenges they always face in Maldives is the high energy cost, actually. They all depend on diesel generators. Like what Kevin just shared 1 or 2 slides before, the cost of diesel generators is about 40 cents US dollars per kilowatt. But some of the engineers in Maldives Island told me it cost them about 70 to 80 cents US dollars because of the transportation as well, right? And then the labor and the storage to handle that. So it's very, very high cost. So due to that, they need to find equipment that is very, very energy efficient. It's not only in the water treatment production, on anything that requires energy, they are willing to pay a bit more premium, but get much more energy efficient equipment, actually. So for the Crossroad Maldives resorts, actually, it was built by a company called Johnson Engineering from Singapore. I still remember the first time I met the Johnson general manager. They are so used to a different type of isobarics, ERIPX actually, that the general manager told me my boss will never change, actually. Then I eventually challenged the boss, why don't you just try it in one of your projects? And once they start using our iSave, they never go back to PX again, actually. That's how they have been doing business with us for the last 5 years. And then they have built quite a number of large projects in Maldives and also overseas. So this is one of their signature projects they have built in Maldives, actually. They have a requirement of about 2,000 cubic meter per day desalination plant. So they build 500 cubic meter per day of 4 sets of APP 22 and iSave 40 combination. I went and visited the plant while they did the commissioning before the COVID. It's a very beautiful plant, nicely built, and the resorts are so good actually that I was telling them, if you give me a good offer, I'll come and stay there, for a few days. It is a must visit, guys. So the moment the lockdown is over, I strongly suggest you guys visit Maldives, actually. So this resort, the desalination plant energy consumption is very, very low currently. Good thing is it's built in a modular basis. When the demand is low, they just run 1 or 2 units, 2 sets of RO systems, and then that enables them to reduce some cost as well. Instead of building a one huge plant, they build 4 different skids actually, because there's a different requirement. When the low season or high season, yeah. So I'm sure they're gonna turn to peak season soon, because Maldives has just opened to welcome visitors without quarantine. So if you need a place to go for vacation, yep, I'll strongly suggest I go to Maldives actually. We also have a case study covering more details from our website. You can download the case study from our website, or please drop me an email. I can share with you more details of this project actually. Well, that's all from my side. And then, yeah, the plan has been running since 2019. Yeah, that's why I say the main saving is on your OPEX actually, guys. And then, as you know, for desalination, your OPEX cost is about 40 to 50% is energy cost actually. So selecting a right pump and an energy recovery device is the trick on saving your energy cost actually. So please do educate the end users on the OPEX cost while you are still bidding for a project. Because sometimes you might say like, oh, you know, this is already specified. Yeah. I have cases where the OEM has won the project, even though the price is higher, just because they can offer a much more OPEX cost actually. So the takeaway from Danfoss webinar today, I think you must understand that our products is the most energy efficient in the market. Therefore, your OPEX saving is huge. Let's say over the 5 years calculation, our ROI period is normally about 9 to 18 months actually, and highly reliable with very, very low maintenance. And of course, we have a smallest footprint compared to any other pumps as well in the motor. So I know some of you have not used our products yet. We're still talking about it. But yes, guys, please do give us a try and you will not regret it, like Yon-san did.
That's right, Vijay. They are great products.
Yeah. Yes.
I just before we continue here, Vijay, can I just answer some of the questions we had during my presentation, because I saw them after the slides here.
Okay.
Yeah.
Yeah, sure. Okay, go ahead. Yeah.
Okay. So just want to emphasize here some of or go into some of the questions. Let me just see if I can push this to the. There you go. So one of the questions that I received was whether, let me just see. So whether the flushing is affected by the speed of the iSave. So just to answer that question, the flushing rate of the pressure exchanger is controlled by the flushing valve down here. And the flushing rate is affecting the iSave's mixing rate. So typically the mixing rate will be maybe 4% at the iSave and maybe 2% on the membranes. But by overflushing with just 2 or 3%, you actually can reduce your mixing with 1 to 2%. So overflushing is recommended when setting up your system. Then another question that I received was whether these pumps could be used for ZLD applications as well. And we do have some pumps that are available for pressures up to 120 bars that are built for these ZLD plants and high concentration plants setups. So we definitely have pumps for that segment or that application as well. Then there was a question whether we could pump. Let me just see if I can find it here. There's one here saying...
in the meantime, sorry to interrupt, Kevin. Can I invite you to switch on your webcam as we go through the Q&A session? We would love to see you. And also just a reminder to... No worries. Just a reminder to everyone, we are now in the Q&A session. So if you have any questions for both our speakers, please do type them in the Q&A box and we will get to them shortly. All right, Kevin, back to you.
Okay, sorry for interrupting there. Okay, so does the Danfoss iSave increase permit recovery? So the permit recovery is controlled by the high pressure pumps. So for the permit production is solely controlled by the axial piston pump. The iSave is only giving you the recovery. It doesn't provide any permit or the pressure into the system. It maintains the cross flow. So you could say the higher speed, the more flow you get from the iSave, the more cross flow you get on your membranes, and thereby you are controlling it will affect your recovery rate. But the permit production can only be affected by increasing the speed of the Danfoss APP pump. So it means the higher speed or the more flow you get from the Danfoss APP pump, the more permit production you also get. But it will affect your recovery rate as well. So there's a question here, what is the application of these pumps, if they can be used for hydraulic systems? They are basically, we have pumps for industrial applications like hydraulic systems, but that's a different branch as this. The pumps we're talking about here for APP and iSaves are all dedicated for reverse osmosis applications. And then there's a question here, is the type of pump applicable to liquid waste? And yes, they are. You can use them for wastewater applications, but we would recommend to use some kind of ultrafiltration or other pre-filtration systems before our axial piston pumps. As said, the pumps are lubricated by the media itself, so it is rather important that the lubricant or the water that we are pumping is in a fairly good quality to avoid debris damaging the parts inside. Then there's a question here wondering what makes the Isobaric pressure exchanger so economical. Yeah, really it is the technology that is used in the Isobaric pressure exchanger is just phenomenal in regards to efficiency. There's no other ERD technology on the market that has an efficiency in the same range, simply because of the energy transfer is done direct by the fluid. So if you look at a turbocharger, you have one loss on the grind side of the turbocharger, and then you have another loss in the shaft. You have a third loss on the booster pump part as well. So there's a lot of areas where you lose energy to heat simply because of the technology. So this is really why the Isobaric pressure exchanger system is the most efficient one. Okay. So then there's a question here, do you make custom iSaves larger than model 70 or smaller than 21? No, really the sizes we have right now is covering most of the demand from the market. You could say that iSave 21 can be, you can just reduce the speed of it and you can go all the way down to 7 or 8 cubic meters. For the model, if you need something bigger than a 70, you can place them in parallel and run them, as many as you wish in parallel to achieve the same efficiency. So with both the pumps and the iSaves, they're really not. You often see that there is a lot of trouble coming when putting things in parallel. But with the positive displacement technology that we are utilizing, it's really not an issue to place a lot of them in parallel because they're not really affecting each other. Then there is one from Eric Pan. When will Danfoss launch the separated pressure exchanger and booster pump version that I saw in Dubai exhibition last year? In this case, what will be the advantage, disadvantage compared to ERD? Yeah, so the pressure exchanger we have developed is kind of it is going to be launched soon. It can be what was the question here? When will the Danfoss? Oh, the advantage here. So the advantage of this the pressure exchanger being not a part of or between the iSaves and the pressure exchanger is simply that if you want to place maybe 20 or 30 of these in parallel, then you can use one large booster pump and place 30 of these separated pressure exchangers in parallel. So that is basically the reason for this product to be developed. We do see sometimes when placing 10 or 15 of the iSaves, if you want to do that, then the complexity of having so many booster pumps in parallel is becoming more complicated than just having one large booster pump in the system. So that's the reason why we developed it. Then there's one here. During startup, is there cavitation with APP? I think there's not really a risk of cavitation. If you're talking about the startup from 0 and up to the minimum speed of the APP pumps, then this is happening so shortly that it really doesn't affect anything in the product as such. There is, of course, as with all pumps, risk of cavitations, but for the APP pumps, it is typically only a problem if you run outside our specification, or you run in a corner where you combine low pressure on the inlet with very high speeds, or so the water simply can't get into the product quick enough. It is not an issue that we have seen problems with. Cavitation is only happening if you're running outside our specifications. Yeah. Okay, I think I got most of it now. Do you have anything to add to this?
I think Mr. Veda Yasin, do we have a case study in Middle East? Yes, we do have some case studies about cases in Middle East. Yep, kindly visit our website. You can download the case studies. Send me an email, then I can drop you the case studies as well. And then COVID, Samrich as well. Case study in Thailand. We do have some references in Thailand, but we have not made any case study out of it actually. Yes, we do have some installation in Thailand as well, right?
There was one here. Do you have any APP pumps with flow rate more than 100 cubic meters? No, we don't have that currently. The maximum flow capacity we have is 92 cubic meters. But again, placing more in parallel is really not an issue. You can place 2 on the same shaft even if you want to. That's the way we solve higher flow demands. Then there's one more here saying,
yeah.
Is the 10 micron absolute filtration mandatory in order to reach 8,000 cubic meters? or 8,000 hours of operation without maintenance. Yes, the 10 micron absolute is mandatory in a way that you kind of, to achieve a high operating hours, you need to filtrate your water. It really depends on what kind of water you have available at your site, whether you need that for the 8,000 hours of operation. But it is recommended if you have lots of particles that you place a filter like this in with 10 micron absolute to achieve the 8,000 hours. But it is not mandatory as such.
I think I've experienced one case in Maldives where we went there for a training, and then they need to bring a pump because our technical manager, Jan Lining, was also there to show hands-on maintenance. And then they just like remove a pump which was in operation for 5 years, and they have not serviced it. And then when they open it, like, yep, it was still in a very good condition, because basically the feed water is like really, really good, actually, quality. Yep. So in that kind of situation, then the 10 micron absolute filtration may not be mandatory. But if you have a very difficult feed water with a lot of particles, then it probably become mandatory before the 8,000 hours. Because there's a wear and tear on the pump, piston, shoes, and other parts, actually, eventually.
But I also recommend that if you have an issue with this, then contact us, and maybe we have a solution for that as well.
Right.
Okay, thank you very much, Mr. Kevin and Mr. Vijay. Their contact details, some of you have asked, is on your screen under the speaker profile, or just type in your question, continue typing in your questions, and we will get back to you either shortly or also via email after the webinar. So just keep them coming. And before we move on, we do have an announcement to make. So if you see on your screen right now, you will notice that we have a contest going on. So it's a photo contest on the Danfoss APP pumps and iSave ERDs. So all you have to do is share a picture of your APP pumps or iSave ERDs, Danfoss, of course, to get a chance to win a brand new iPad Pro. So it's so simple. Just snap a photo and email it to highpressurepumps@danfoss.com by end of this month, which is 31st October. And include details such as your plant name, plant size, plant location, and the Danfoss product model and size. If you want to find out more, the link is also under the reference box. So just click on that link and it will bring you to the terms and conditions of this contest. Or you can also just type the address that is on your screen right now, and it will bring you there. So I do see we have one more question. Oh, sorry, this is answered, I think. Yeah. So before we end this session, I would like to invite Mr. Kevin and Mr. Vijay back to switch on your webcam. And maybe if you can share any last words you have with our audience today, whether it's 3 key things to remember from today's session or any other message that you'd like to share as well.
Yeah, I would say remember that if you want high efficiency, you need to think Danfoss and use APP pumps, obviously. And also, please contact us if you have any questions about the iSaves and the use of them. There's lots of opportunities also within ZLD with the Danfoss products. So feel free to contact us.
Mr. Vijay, do you have anything to say to our audience before we end this session today?
Okay, I just want to share like what we said, like try to spec in Danfoss products much more earlier, because you need to educate your end user on the energy efficiency. If they understand, then they know they're going to save a lot of money on their OPEX eventually. So that is very, very crucial. Yep. That's all from my side.
Yeah.
Okay, thank you very much once again to Mr. Kevin and Mr. Vijay for a very detailed presentation. We hope all of you found this very useful, and please feel free to reach out to us via email if you have any questions later on. So thank you once again for joining us. Have a good day.
Thank you very much, guys, for joining.